Great. Well, welcome everyone, and thanks for joining us today. So we want to highlight a few items as we get started here. As attendees on the webinar, your camera is going to be turned off and you'll be muted. But if you do have questions during the presentation, we ask that you please use the Q&A tab at the bottom of your Zoom screen, and you can enter any questions there. We do want this to be interactive. A Q&A session will follow the main conversation, and we'll address questions at that time. And Turner's going to help us to figure out the most relevant questions that are asked most frequently by participants. We are recording this presentation today, and we'll make it available when it's ready, usually within a week or two, sometime sooner. If you hear or see something from our panelists today that you'd like more information about, feel free to send us an email, and we can set up a one-on-one call to discuss more, and that's going to be with any of us, me, Joe, or Trevor, or Turner. And so let's jump right into some quick intros here. So I'm going to give a quick intro of each of you guys, Trevor and Joe, and then you can tell me if I got anything wrong, or feel free to add. So Trevor Matthews is the founder of refrigerationmentor.com, and he's passionate about education and personal development. And I think that's going to come through today. Everyone is going to see that. Refrigeration Mentor is all about training, education, and mentorship to support and make a positive impact in the refrigeration industry. Prior to founding Refrigeration Mentor, Trevor was an HVAC refrigeration training and development specialist with Emerson, I believe leading a lot of the training efforts for related to HVAC and refrigeration. Is that right, Trevor?
Yeah.
Very cool. We're very excited to have you here. Thanks for participating.
I appreciate the invite. This is awesome.
Yeah. And we also have Joe Tenca. Joe is the CEO and president of Omni Mechanical Solutions. Omni specializes in refrigeration and HVAC construction, controls, maintenance, commissioning, and consulting, and prides itself in offering its customers the most highly trained and well-diversified techs this trade has to offer. Joe has over 25 years of experience working in the HVAC and refrigeration industry as a hands-on tech who has come up through the ranks and is now running his own company with a really great group of technicians. So I get most of that right, Joe?
Yep. Yeah, that's about right. I'm really excited.
Yeah, we're really excited to have you here too. And so for folks who don't know, when people ask us to recommend technicians and maintenance companies and they're in the Bay Area, Joe's our first call. And we do get that question a lot from various parts of the country. And yeah, so it's really great to have folks like Joe in our court who we can trust to solve problems rather than just make the food cold. And we're going to talk a lot about that topic today. So let's get into our agenda as a next step. So today, the topic, of course, is compressor failures and the fact that compressors don't typically just die of their own accord because of manufacturer defects or whatnot. Usually they're being killed by some external set of factors. And so we're going to go through 4 key categories. And we had a little bit of disagreement on exactly what these categories should include or how they should be grouped. But ultimately, I think we're all in agreement that there's this pretty small number of key issues that ultimately result in most compressor deaths. And so these are some of the topics we'll cover today. This is not meant to be comprehensive. It's more to enable a conversation between folks like Trevor, who are all about training, folks like Joe, who are all about making sure that things are working properly and fixing them when they don't. And then Axiom, which is providing software to help optimize and avoid these sorts of failures and ultimately predict them and fix them before they turn into a big outage, related to compressors, related to other systems as well. And so those 4 key topic areas are floodback or liquid slugging, overheating, oil loss or short cycling, and finally contamination or electrical issues. We'll go into a couple of case studies after that where we've seen these types of issues in practice in the field in real grocery stores. And then we'll spend the rest of the time on Q&A. So our first topic area is floodback or liquid slugging. And so the way that I like to talk about this is essentially compressors are made to compress gas. They're not made to compress liquid. In fact, liquid is incompressible if you guys remember your high school physics. And anyone in the refrigeration industry knows that if liquid is entering the compressor, that's really, really bad. And trying to compress liquid can result in pressures as high as 3,000 PSI, which is not good for anyone involved, any stakeholder. So right off the bat, this is less about kind of teaching you guys the ins and outs of each one of these failures and more about hearing stories or hearing, I guess, examples of what we've all seen in the field. So maybe Trevor, can you start off by giving us an explanation of the different ways liquid refrigerant can end up in a compressor crankcase? What's the difference between floodback and liquid slugging, for example?
Yeah, so really anytime a compressor is running and liquid refrigerant returns to the compressor, that's considered floodback. And it happens different to different compressors. So if you talk about, say, a semi-hermetic compressor, if you have really low superheat, and I've seen this tons of times where it's either the mechanical valve, the metering device is not set up properly, or it has failed open, or something jammed in it, and liquid just continues to go even though it's supposed to close it off, satisfy that evaporator, it makes it back while it's running, and then it starts to dilute the oil, and then it starts to wear parts in the compressor, starts to wear the bearings, and then it reaches to the point where you have a mechanical failure, which then turns into an electrical failure. And this is one of the big things, see this a lot. A lot of technicians out there will go up, and I've even did it. I was in the field for many, many years, and I'll go, oh, it's a burnout, it's an electrical failure. Let's get a new compressor, change it. Didn't really know what the root cause was. And that's why you have to dive in to find out, was it that floodback? And was it the floodback that made the bearing wear, that dropped the rotor onto the stator to cause the electrical failure? So there's a whole process in it. But you really want to make sure that you're not getting, like you said earlier, liquid into the compressor while it's running.
So that's the beginning of kind of a sneak preview and how much of a detective technicians have to be ultimately, and looking at 2, 3, 4 steps back of the chain of potential failures here to find the root cause. Joe, one thing that you said during our prep session was something that your mentor had said to you, and it really stuck with me. Where your mentor was asking, did you fix it or did you make it cold? Do you want to talk about that a little bit? And especially, I guess, how technicians are kind of inadvertently killing compressors by making it cold rather than just fixing it.
Yeah. So when I was coming up, my journeyman always told me, it would ask me, did you fix it or make it cold? And, when I was younger, I didn't understand it as much. And then as I've progressed through the trade and ran into more issues and whatnot, it made more sense over time. But a lot of times, like what Trevor was saying, guy goes in, technician, and goes, oh, it's a burnout. Compressors, windings opened up, whatever happened, it's electrical problem. But really, you look back and that compressor may have been reset on oil failure without anyone really looking into the root cause of it 10 times prior to that over, a 1 year period. And, it's common to go in, reset it, check everything looks good, and you kind of just go, oh, it must have inadvertently failed. But that's not usually the case. If a compressor is off an oil failure, then something did happen, whether it ran out of oil, it was liquid contaminated in the refrigerant, so it was thinned out and lost its pressure. And sometimes you got to go back and do more research, when in uncommon times, especially nowadays with the technology out there, it's pretty, you can look through the computers and the controls and look to see, suction temps and systems coming out of defrost to try to figure out, is there a possibility to have liquid flood back at one point?
Yep, makes total sense. All right, so now let's talk about some quick prevention methods. So, some of the things that obviously each one of these types of failures, there's a period of time leading up to it when things start to go in the wrong direction, things start to go south. And so you can start to detect those leading indicators through real-time superheat calculations, or you can avoid them entirely by installing suction line accumulators or crankcase heaters. Obviously, those are kind of like, an extra layer of protection against these sorts of failures where liquid is entering the compressors. Do you guys have any thoughts on how to use data? Or I guess maybe Joe specifically, do you have thoughts on how data can be used to avoid these types of failures, floodback and liquid slugging, and better monitoring, better data, better analytics?
Yeah, I think most retailer or most refrigeration systems now have control systems, and they have sensors on, even if it's just one sensor on the suction header. there's enough information there to kind of see what the system's doing throughout the day and night and whatnot. And I mean, it's there for a reason. And sometimes one thing I've always found is sometimes you find that the suction header sensors aren't in the ideal location, and they're on the far end, or they're kind of in a obscure part of the header where there's really no systems. So sometimes you can get some poor readings on those. So it's one of the things, like when I did startup, even though it was something really minor, is I'd always verify where the actual sensor was and try to make sure it's located by my larger loads on the circuit, to make sure I'm getting accurate readings from that, because control systems are there for a reason, and it's good information to have. One other thing I like doing is, and I like taking the total superheat on systems quite a bit, for liquid slugging, and what we'll talk about in the future here is overheating, because I think total superheat is something people don't really talk about as much as they should, but it's the number one thing compressor manufacturers are worried about, is a total superheat at the compressor.
Can you talk about the difference between total superheat and kind of the superheat in the suction header?
Yeah, well, so the total superheat is usually you read it at the system. So you read it, at the EPR or the whatever device is at the rack, suction stop, whatever it might be. You take superheat at the header for that circuit. And you can go across the whole header. And I mean, if they're all within, 30 degrees, let's say 20 degrees total superheat, something like there, but you've got lower at the header. I mean, something weird might be happening, but yeah, I like using total superheat, especially because you can't get into, grocery stores are in business. They're there to sell food. That's what they're there to do. They don't want us climbing through their freezers and coolers while they're trying to operate. But at the same time, you got to do something. You got to check and at least start working on it a little bit and figuring out what you can do. So it's total superheat's one of the things I talk to my guys a lot about just checking total superheat for now. Let's just see what we can do when we get back and schedule something.
Yep. And then Trevor, on your end, when you're seeing these sorts of failures, obviously, like Joe was saying, a lot of this data already exists. Is it being used today? How are refrigeration technicians or other stakeholders, consuming this data, using it to ultimately help prevent these sorts of failures, or are they not using it?
Yeah, so it all depends the application. Like if we talk about CO2 refrigeration, it's being done there in standard synthetic racks. It's still happening. It's there. A lot of the things that you can check for Floodback, for example, the big one's airflow. You can measure the airflow. You can measure the oil pressure differential. Because if you start to lose oil pressure differential, you could be washing it out with refrigerant. It could be something else, but it's a good sign that it could be Floodback that's happening there. So there are so many different things that you can check, because if your oil reservoir is full, but it's still washing out the oil, by analytics, you can tell, okay, my oil reservoir is good. I should be feeding. Now my compressor doesn't have any oil in it. The differential is too low. That's probably Floodback happening. So there's lots of different analytics you can do. Measuring the oil temp, measuring the discharge temp for Floodback. So checking your, Joe was saying, your system superheat, you can call it compressor superheat as well. Knowing exactly what's happening to that compressor. You get discharge superheat as well to tell if liquid is condensing inside the compressor. So there's so many different analytics you can do. It's happening now, especially on the newer systems, like I said, in CO2 refrigeration. The older systems, some people are starting to add more of these sensors and stuff, like for the airflow. There's a big one, people. It's airflow. You don't have airflow, your temperature of that evaporator coil drops right off, and then you start to get liquid going back. But another big one is electronic valves. We're going to see more electronic valves coming out, and I'm seeing them in synthetic refrigeration. It's the only thing you use in CO2 refrigeration, and you just tell the superheat on every single case, every single box, and you can monitor that stuff, and it's all done through analytics.
Yep. So we haven't talked about this in our prep, but one thing that we have seen at Axiom has been that our customers, especially in situations where the retail grocery chain, the alarms are being fed to the local store manager, they'll tend to prefer fewer alarms overall, and so they'll shut off all the non-critical ones and they'll only focus on the case temperature alarms. And so all these different sensors and all this data and all these different analytics that you just talked about get ignored because they're not a case temperature alarm. So I wonder, is that kind of matching what you guys have seen out in the field as well?
Yeah, and for me, yeah, I mean, it's like I said, they're in the business selling groceries, but there usually still notices in them, whether, the different kind of controllers. So the technician themselves should be able to get on site and see the notices that maybe the managers don't get, or the whoever's in the charge of the facility, they don't see those alarms. But when the technician's on site, that data is still there. It's still available. I mean, it's a good point. A lot of people get stuck on chasing the alarm, but usually the alarm's created by something else. And if the controller's set up right, that information should still be in there, even though it's not generating alarms to the, to whoever's in charge of the facility.
Yep. So it's there, it's ready to be found by a technician who's willing to dig in and figure it out.
Yep.
Great. Let's keep going, Turner. All right. Next up, we have overheating. So obviously, overheating means the compressor is getting too warm, which is bad. That can be caused by high superheat, low refrigerant charge, or fouled condensers, among other different failure modes. This can lead to essentially poor lubrication, premature wear on the bearings, seized compressors in the worst cases. And then that also leads to oil fouling and things like that, which can ruin everything else in the system along the way, all the other compressors too, and valves and whatnot. So I guess right off the bat, Joe, what are some of the different reasons you've seen for overheated compressors, or what's a recent overheated compressor that you've seen? What was the root cause of it?
I mean, with the newer refrigerants, I mean, a lot of it, the superheat's always been one out there. There's a fine line between the valve being set just right and maybe being a little too low, depending on how much working of the the freezer, the cooler there's done during the day, where that coil could be perfect 6 to 8 degrees superheat when it's not being worked, but they leave the door open all day and now it's flooding back and there's no strip curtain. So there's kind of a fine line on that. Another one for me is just the superheating of the compressor, whether it's a Y1037 valve, demand cooling. I think Bitzer's using the BMT kits now, is what they're called.
So de-superheating is essentially spraying a little bit of refrigerant into the suction header, right?
Into the or into the compressor body itself. I think a lot of people think, well, it didn't trip off on it, so it must be fine, but that's not necessarily the case. Sometimes those things are there to prevent it from tripping. So sometimes, the compressor may be running too hot. It just hasn't hit the max point where it's going to lock out. But the actual, the added cooling is not working. I see it a lot. We see it a lot on these retrofits we do. So.
Yep. One thing, and so I guess, yeah, Trevor, on your end, when you're talking about training technicians, is this really top of mind? Or is this kind of lower on your list of failure modes to keep an eye out for?
No, overheat is probably the number one failure of compressors in the industry. And the biggest one is compression ratio. I don't think enough technicians understand compression ratio. And when you start looking at performance charts, and this, I had a training last night talking with a bunch of refrigeration professionals, you need to understand the performance chart of that compressor. And when you start running high compression ratio, more heat of compression, more work on the compressor, you start to heat up more, your oil start to get more viscous, it gets thinner, so your pump out rates go higher, and then it leads to a bunch of problems. And this all can be done through analytics if you want. Really what the technician needs to understand is that anytime the compressor is running outside its envelope, it's damaging the compressor. These manufacturers that are building these compressors, they're building them for 15 years. But I've seen them for years, 2 years, 3 years, 5 years failing. And what the compressor manufacturers have done, like Bitzer, Copeland, Danfoss, all of them, they're adding features for customers to buy to protect them a little bit more. DLTs, which is discharge line temperature protection. So if that temperature gets too high, it shuts down the compressor. Because when that oil starts to overheat, you have a world of problems. And there's so many different things we can talk about. Dirty condenser, a suction filter dryer is another big one. You got to take those things out. If they're plugged, you get a pressure drop on your low side, so you get lower suction, higher compression ratio, more heat, more work on the compressor, leads to more damage. And it doesn't usually happen, especially with overheat, it doesn't just happen. This is community, like it's weeks and months and years of damage to the compressor because these compressors are built good, but it works and it breaks itself down. One technician goes in, oh, it was a bit overheating, let's fix this. So I cleaned the condenser. But did they fix the real problem? Maybe the condenser was dirty, but there's 3 other problems like the superheat that Joe was talking about, or the demand cooling or liquid injection not working properly. Because they cleaned the condenser, it cools it down, but it's still not the bigger picture of what's going on.
Yep. Yeah, I think that's kind of getting into another topic that I wanted to bring up, which is related to, so Joe, you had talked about kind of the difference between the contractor mindset or the maintenance technician's mindset when they're on a contract basis with a customer or kind of a maintenance agreement where it's a fixed price each month versus a T&M time materials mindset. Can you talk a little bit about kind of the pros and cons of those and how that might be contributing to, essentially what Trevor was just talking about, which is, not solving the root cause of the problem?
Yeah, I mean, I've been doing this quite a while, and I've kind of seen the evolution of the service contract within retailers. And I think there's a mindset of, it's all the way from the top. I mean, it's not the technician. It funnels down from the very beginning when they bid the contract of, we're trying to keep costs down in order to fit within the envelope of what the contract amount is per month. So at that point right there, you're handcuffing a technician for the most part, because now, like what Trevor said, the technician's going to go in and go, oh, condenser's pretty dirty, I'm going to clean it, I'm good. Let's move out and move on to the next call, opposed to, digging into it more, checking, yeah, the condenser was dirty, but that's just what created the major problem. There's still an underlying problem. A dirty condenser shouldn't cause compressor to stop running. I mean, that should just be something you start running higher discharge and get some alarms on it. But if you have compressors tripping or, going off on oil because oil's thinned out, or going off on demand cooling or overloads or tripping breakers, it's not a dirty condenser, but technicians are kind of limited what they can do with contract accounts. And it can be, there's pros and cons to them, but I think the biggest thing is they need to be set up to where the contractor can still get to the underlying problem, the root cause, because sometimes it's not just the first thing you find, and there's many layers to peel to get to that problem. So T&M, not as bad. I mean, you can usually get in there and dig around and find more, and ultimately, long-term prevent failures of compressors because you have the time to go in and properly diagnose them.
So what I'm hearing is kind of the way that contractors think about these 2 different contract structures is that if it's a maintenance agreement contract or, a fixed price per month, their entire mindset is going to be focused on minimizing cost, and therefore minimizing time spent on site, so they can, get to the next job essentially. Whereas if it's T&M, then that mindset's a little bit different, and they're going to be willing to spend more time digging in and finding the root cause. Am I getting that right?
Yes. Yeah. Yep.
Makes a lot of sense. Yeah, really interesting. There's another question I had for you, Trevor, here. So yeah, another question I have is, Trevor, what actually happens in a compressor when it overheats? And I guess even before we jump to that, one thing that you were mentioning is how these manufacturers are adding a bunch of safeties. What's interesting to me about each of those safeties is that that's almost like the last line of defense before there's something really catastrophic. So yeah, maybe those can prevent catastrophic failures, but like you were saying, if you're running at the margin and you're running this compressor really hard outside of its spec, maybe you didn't trip it off, but you're still wearing it down and shortening its lifespan significantly and increasing the risk of near-term failure a lot. And so I think it's interesting that all these different features that are coming out are more about preventing catastrophic failure, and they're less about making sure the compressor is operating within an optimal envelope. Am I getting that right, Trevor?
Well, once again, it all depends on the manufacturer, and all depends on the device. There are some that will protect it and shut it down, but lots of times technicians don't understand the technology and they'll jumper it out. The whole point of this is all these devices that compressor manufacturer is to notify the person who's doing the maintenance or the service to let them know something's wrong. At the end of the day, even you can have all the best devices in the world on there, but if someone doesn't recognize the problem, understand the problem, and to be able to fix that root cause of the problem, the devices are only going to protect it for so long, because you only can trip a compressor off so many times. And it's really important to educate your teams or the technicians that are working on this equipment about that technology and how it benefits them. Right. So they're doing a great job, but once again, they're not miracle workers.
So step one is make sure you have the right sensors. And then step two is make sure that the technicians can access the data. And then step three is make sure they actually understand what the heck they're looking at.
Yeah. For example, Bitzer has something called the IQ module. It may even hook up to Axiom Cloud, but it does everything. It does you can do your suction temperature, your discharge temperature, your pressures. Copeland has the CoreSense diagnostics for semi-hermetics, or CoreSense protection. It does the same thing, oil pressure, all the stuff. It does it all. But at the end of the day, if someone just keeps going and press the oil reset button or the alarm reset button, it's not going to protect the compressor.
Yeah. Yeah. And tying it back to one thing Joe said is, even if you have the right sensors, the techs can get to the data, they understand what they're looking at. That step four is then, do they feel so much pressure to leave site and get to the next job that they're actually going to deal with the root cause, or, basically giving them the incentives or the space to truly solve the problem. And that comes back to the contract structure. And so maybe what I'm beginning to hear is that you need all four of those pieces to really truly solve the root cause of this. And there's one other thing that came up yesterday, which was really interesting, about basically some percentage of technicians who are really uncomfortable getting into the controller and looking at data. Joe, is that you who brought that up? I
believe so, yeah. Yeah.
Can you talk about that a little bit? I think that was really insightful.
Yeah, I just think it's probably is a lack of training. I mean, even though I think companies do a really good job trying to train their guys, and I don't think that's the case. I think between the companies trying to train their union companies, what they're trying to do, I think the companies, everyone's trying to get enough training out there. But people there's still just not enough. There's not enough information, training. Maybe, I know there's a lot of talk about training now, and classes and stuff I see all over the internet and LinkedIn stuff. So I know it's a focus, but I just think there's so much information out there required to do what we do. It can be a little cumbersome for people, mechanics, to think I need to know all this stuff. And, so I do think sometimes they'll walk into a store and see a controller and just go, I don't know anything about that thing. I'm going to put gauges on this and figure it out from there. Where, the computer should tell them everything they need to know. And you verify it with your gauges, but a lot of the information coming from it, you should kind of lead you in the right direction, and then you verify with your tools.
Yeah, so, in case those computer connected sensors are out of calibration or something.
Yeah, but that should lead you. You get a big picture by looking at the control system. Trevor said CO2. It's one of the reasons I love it is you don't use gauges on it, and it's got sensors everywhere, and you can see you can see what the entire system is doing from the controller. So our space is going there where that's going to be what people get used to. But I think, right now there's still a lot of people out there, mechanics out there, that just aren't maybe comfortable or just familiar, used to going to the controller first. There's a lot of the put my gauges on and use my meter. And I'm not saying don't do that, but I think there's a lot of information we found in the computer system to see what it's doing. And it's what controls it. So if a transducer's off, then the controller can't control the compressors properly anyway. So, you use it to see what's going on, but you also have to use it, to verify that it's controlling it properly.
Yeah. Yeah, I think another key insight here is that, when a technician is uncomfortable getting into the controller and looking at data, and they're relying on valves and taking their own measurements, that means they're only getting a snapshot in time of what's happening at that facility, rather than, really getting the benefit of seeing a lot of data over time. And looking at trends and things like that. I think that's a really key insight as well. Cool. So I am not managing time that well. Let's go faster here. Turn, you want to go to the next slide here? Perfect. Oil loss or short cycling. So obviously, when there's not enough oil in the compressor, that's bad. This can be caused by the oil line being blocked, not enough oil charge in the system, or other problems related to sizing, relative sizing of compressors versus oil reservoirs and things like that, or oil, supply valves or whatnot. And so we've talked a lot about things like oil differential pressures, oil temperature monitoring, et cetera, to help identify these problems before they turn into a major issue. Obviously, short cycling can be another major root cause of oil issues, really, because oil takes a few minutes to really start kind of washing throughout the body of a compressor. And so I guess right off the bat, Trevor, how does this stack up against the other failure modes that you see in your trainings when you're talking to new technicians?
Oh, there's a high percentage of oil failures. And once again, this is something that a lot of technicians don't dive into it because it's unknown. I can't see it. It makes them uncomfortable outside the comfort zone. They're not confident on it. But oil loss, oil failures is another big failure, but it's usually caused by something else. Like you could have floodback that washes out the oil. Like you're saying, short cycling, the compressor turns on for a second, shuts off, turns on, and it just keeps to have a higher pump out rate. It pumps out oil all the time. But really, one of the biggest ones I've seen is usually pipe sizing, trapping, and sloping. That's one of the big ones that over time that can happen. Another one's logging in a really cold evaporator. And you can really check all that stuff using your control system, E2, Danfoss, microthermal, RDM. It doesn't matter who you use. A lot of this stuff it kind of see and track. And it's important to understand because you need oil. Overheat's another one for oil loss because now you thin it out. It's going to just not do its job, not going to lubricate. But it's important to understand that. And then with oil management system, when we talk about a rack application, there are so many things that you could potentially do. Western Meyer has a good device that Joe was talking about the other day, the differential. You got lots of pressures that you can really monitor. So I know really good technicians, before they even touch anything, they go and they review what's going on with the control, the whole system as a whole, looking at the lights, the fans, checking that monitor system, checking the oil, see if there's oil in the sight glass. You do not have to take out your gauge and temperature probe right away. Good technicians go and assess the site, and they will know right away if there's a loss of oil.
Makes sense. Joe, have you seen a recent example of this out in the field?
Oil loss. All the time, and oil. Oil is just one of those tricky things where it's just so many different things that can cause it, from the oil system not working, like Trevor said, floodback coming in, hitting the compressor, cycle rates. Oil is probably, I would say, probably the hardest thing to troubleshoot on a compressor when it's not happening. Because there's just so many factors into it. Where does it sit on the bench? Where, just so much that comes into play. And it always seems to happen when you're not there. So it never happens when you're on site. There's a compressor trip in front of you and you go, oh, look, there's no oil in the sight glass. Or no, look, the sight glass is full, but the oil, it pumped it out real quick and refilled it instantly. So it's definitely a tricky thing to find. And it's very complex. All the oil systems are different. You got some that are high pressure, low pressure, some that use an OCD off the top of the reservoir, some that use the little oil valves. That was a common thing for a long time, those oil valves plugging up and getting dirty, especially under high load. So they just couldn't, they could feed enough when the load was low, but if it got really high, the little, I forget the model number, but the little oil valve just wouldn't feed enough oil. So you have to pull it apart, clean it. And then as soon as you clean it, you got your flow rate back to fill all your compressions up.
And so I think that's another perfect example of, hey, I wasn't on site to see it. And so pulling out my gauges or looking at sight glasses just doesn't help. What I really need to do is, as a technician, is look at historical data. to see what happened, last time there was an oil trip, for example, and try to diagnose using that. Am I getting that right, Joe?
Yeah, I mean, because oil, ultimately, I think sometimes oil system is all based on the amount of load on the rack. Because when the load's off, you don't have a lot of compressors calling. A compromised oil system can keep up with the demand of the compressors. But when it's, hot out or the loads of product are coming in, you got all the compressors running on that rack. That's when a compromised oil system just can't keep up, and you'll get these intermittent failures because of, all sorts of things. A lot of them you'll see, especially these older stores where they've added capacity to the racks, is the old the helical style oil separators are undersized now. So when you've got, you got 10 compressors on a rack, and when all 10 are running, it just stops separating oil.
So all the oil ends up going out to the evaporators.
Out to the evaporator, you're just 100% relying on return on the suction lines, which then, like Trevor's stating, it doesn't always work that way, because cold coils, bad piping, not enough slope.
Before you know it, your reservoir's empty.
Your reservoir's empty, and you don't know why. But it's
pump some in,
sometimes.
Joe. Let's get some oil, pump some in.
Yeah, fill it back. Just put more in there. Eventually, we'll get it full.
I've been on both ends of that before, and then you end up with too much oil in the system, and that's another whole problem.
Yep.
One thing that took me a little while to understand when I was entering the space, years ago, was basically, why does short cycling cause oil issues? Trevor, can you talk to that just really quickly?
Yeah, so every time a compressor starts out, there's something called oil carryover rate. So when it starts up, there's a lot of pressure, and it'll shoot out a little bit of oil. So what you need your compressor to do is to run for a certain amount of time to move the oil through the system to get it back. So if it starts up and shoots some out and it shuts off, you don't have run time to make that oil to travel with the vapor, because it's way harder for oil to travel with vapor than with liquid. And so you need to get it to travel all the way through the system and back. So if you start up, shut off, start up, shut off, start up, shut off, start up, shut off, you keep just shooting out little bits of oil until you don't have enough runtime to make it come back. And really, that's how it works.
And the rule of thumb that I've heard is that you got to have compressors running for at least like 8 minutes. Does that match what you've heard?
It's all different with different manufacturers. You want them at least 2 or 3 minutes for sure, but you'll see, depending on the manufacturer, it could be 6 times an hour, it could be 12 times an hour, it could be 20 times an hour starts, but you need to look up the compressor manufacturer specs.
Yeah, makes sense. All right, let's keep going, Turner. All right, our last category is contamination or electrical issues. And so what this is, degradation of refrigerant or electrical components. Basically, one thing that I like to think about, if you kind of zoom out and think about this topic as a whole, is that you have this compressor sitting in the center of your diagram. Then there's all kinds of inputs and outputs, and each one of those is a way to potentially kill the compressor. And so if you put in dirty refrigerant, that can kill the compressor. If you put in dirty electrical current, that can kill the compressor. Or if the electronics are malfunctioning and sending weird electrical electrical waveforms into the compressor, for example, that's bad too. So this can be the root cause of this can be moisture in the refrigeration system. So this can be non-condensables or moisture or water, improper wiring, dirty gauges that can be adding, again, these non-condensables or other impurities into the refrigerant and oil system. And ultimately, this can lead to things like overheating, contactor failure, which again will cause the oil to go bad. Essentially, I'm forgetting the word now, or get contaminated. What is it? Delaminate? What's the word? What happens to oil when it gets too hot?
So to break down, lose lubricity.
Okay. Fair. So how can you prevent it? Power signature analysis, minimizing the use of gauges. So let's see here. So Joe, how prevalent are corrosion issues when you're going to these mechanical rooms?
Like contamination. A lot of them, I'd say contaminated more, not corrosion as much, but contamination. You'll see a lot of dirty oil, which can come from like any of these things we just talked about. Heat also breaks down the oil and makes it so it eventually becomes pretty acidic just from just cooking it essentially. I think this one of the things that goes overlooked a little bit is the quality of the oil in a system. And I mean, it's the main thing. It lubricates the compressors. And if it's compromised in any way, your compressor's not going to get proper lubrication. Like Trevor said, the safeties are in there for a reason. It's like an oil failure is at the minimum of what the oil pressure is supposed to be. So, if the oil is breaking down over time, losing its viscous, or it's got contamination in it, and you're just, it's running through the system, plugging everything up, getting dirty, you can run on low oil pressure where that compressor is still not getting the proper lubrication over time and wearing out all the journals and bearings and everything. But it still hasn't tripped anything off. So it's kind of one of those things where you just got to be aware. A lot of the retailers do have oil test kits and want the oil tested and everything. Cleaning it is not the easiest thing to do. A lot of people have different ideas of how to do it. But it's definitely worth the money to either try to clean it or even change it out if it is contaminated.
Makes sense. And then Trevor, on your side, what types of electrical issues have you seen most frequently?
The largest percentage is from mechanical failures. So from what we talked about already, floodback, flooded starts, slugging, oil issue, contamination. That's what causes electrical issues. There's only 20% of the time there's a true electrical issue from like the grid or from the contactor or whatever. Most of it is from really mechanical failure. So there's a kind of a rule. It's an 80-20 rule. 80% of the time, the compressor fails by a mechanical failure. 20% of the time, electrical. But most of the technicians see it as 80% of the time as electrical failure and don't understand that it's a mechanical failure that caused that electrical failure. A true electrical issue would be like your contactor welded, or you got a failed contactor, or you got a rub through and it shorts the compressor out, or you're not wired up properly and you got a loose lug on there and it starts to arc. And I see a lot of misdiagnosing electrical failures for sure out there because you need to dive into that root cause. And like we're talking about contamination, Joe had a good point about acid starting. So from day one, if the system is not installed properly, if you don't pull a proper evacuation down to 200 microns or 500 microns and holding there, and you have moisture in the system, the compressor doesn't fail after a week, after 2 weeks, after 6 months. Sometimes it's 4 years down the road because of that day one installation, even though it ran for 4 years and kept temperature. Each day, each week, each month, it started to degrade that oil a little bit, and then you get something called copper plating, which eats away at the windings, and you can see it inside the compressor.
Yep, and then the moisture is reacting to form acids, right?
It's called a reverse hydrolysis effect because POE oil is made of water. There's a portion of it as water, and so when water gets in with it, moisture gets in with it, it's called reverse hydrolysis effect. So it turns it back into its acid state because it neutralizes acid and water. POE oil is made of.
Yep, makes sense. So Trevor, one thing that we haven't covered today, we're already at our last failure mode that we did chat about, and I think is really worthwhile. You had mentioned yesterday that 30% of compressors are still working when they go back to the manufacturer to be diagnosed for their root cause failure. So it has something to do with misdiagnosis in the field. Can you talk about that a little bit and some of the root causes for that sort of, that trend that we're seeing in the space?
Oh, for sure. And you'll talk to different manufacturers. You'll see some that'll say 20, some will say 40 to 50. All depends. So you'll see the highest rate probably on single phase compressors misdiagnosed, but you still see it on large 6-cylinder, 4-cylinder scroll compressors. Because there's an underlining when you're troubleshooting something and you see something right away, you put your meter on you use your meter and you check it and it says, oh, it's open. Oh, it's open again. Oh, I must have a failed winding, but maybe your internals are open. I've seen lots of that. Or for example, your internal line break, or on a single phase compressor, you have a bad run cap, or you have a bad start cap, or you have a bad potential relay, and it's not properly checked at that time. When a technician really understands the component, it it makes it easier to troubleshoot a system. You need to know all of them. So when I worked at Copeland, I seen a lot of them come back, and I would put them on the test bench with the team, and we would just turn them on. They would run. I sent many videos out to technicians, and this happens with Tecumseh, Bitzer, Danfoss, Durain, Bach. It doesn't matter the compressor manufacturer. They see it because it happens. A lot of misdiagnosis.
And so, Joe, you were mentioning that obviously this can snowball into a very, very expensive on-site repair. Can you talk about why that is relative to warranties and cranes and whatnot?
Yeah, I mean, a compressor, not only the compressor itself is expensive, but everything that goes into it from, I mean, if it's done right, you're going to change contactor controls to test them. If they're old, I always recommend changing them regardless, because it's what protects the compressor. So if you're putting in an investment for the customer, I always change out the controls unless we know they're brand new, because they're there to protect that compressor. So you got that, the crane, getting the compressor back to the wholesale house in order for the core to get exchanged. It's extremely costly. And the warranty, if it has one, only covers the actual compressor, but not the labor that goes into it and all the other stuff. And especially nowadays, a lot of the retailers procuring their own equipment now, so there's not being sold to them by anybody. So really, you're relying on the OEM warranty, which there's not enough in it to cover the labor it actually takes to change out a compressor, depending on where it is, on the roof, inside the back of the store. They're all over the place. So
you guys are telling me that 30% of the time when a $5,000 compressor fails and the retailer ends up paying, $20,000 to swap it out with a brand new compressor with a crane and, stopping traffic and cutting a hole in the roof and whatnot. And then that compressor gets shipped back to the manufacturer and Trevor turns it on and it works. That sounds maddening.
I don't work at the manufacturer.
Yeah. When you used to. So that's maddening. And so how could we as an industry avoid that in the future? I assume it comes back to data.
Training. It's not even data, it's training. Data will help. But if you have a busted valve plate, you can do a few things to kind of tell it, but if it's on a rack, it's hard to tell. You got a busted valve plate. So all the technician would have to do to get the customer up running would be replacing that valve plate. Unless you put a sensor on every compressor, every discharge and every suction, maybe you'll be able to tell if it has a busted valve plate. And then there's still checks that you need to do. So it's complicated. It's complex, but not. It's complicated, but not as complex as it is. I don't know.
Yeah. So it's about going on site and running the tests in order to collect the right data, is what I'm hearing.
Yeah. So you physically have to do stuff inside the compressor to see if it's that. So a lot of what happens out there, what I see more and more, is that contractors will replace a compressor, even though if it's a valve plate, just in case there's something else going on and the technician misses that. So they'd rather for their customer, replace an expensive compressor instead of just doing a little bit of repair, because that compressor, say 8 years old already, and then they do a really expensive repair and it only lasts another 6 months or a year, then it would have been better for them to replace that compressor. So there is a fine line as well.
Yeah.
And Joe would know this. Sometimes you have to make a decision. Let's do a repair. Let's do a replacement. And that's up to the call on the technician.
Yep. Makes a lot of sense. All right, let's get into a couple of case studies really quickly here. So this is the first case study. Basically what we're looking at is, this is something that actually happened in a real grocery store earlier this year, or actually I guess in December of last year. Basically, this is an example. So what we're looking at is the temperature of one specific case group, A6B, in this grocery store, and then the suction superheat for that particular suction group. And so you can see that basically a technician came in and cranked open a TXV, and that caused the temperature to get down to where it needed to be. So that was he made the food cold type move. However, that also caused the suction superheat to drop to 0 on that particular suction group. And so this is an example of making the food cold, but not solving the root cause of the problem. And so, this was basically by using data to look at these trends and identify, hey, these two things happened at the same time. The temperature got fixed, but the superheat dropped to zero at the same time. This is not rocket science, but by looking at that historical data and making that comparison, that was enough to help us figure out, what was the root cause of that suction issue, that suction pressure, the suction superheat issue. Let's keep going to the next one. So this is an example of using data to catch liquid slugging. Basically, there was an improper defrost termination that was set up that was being used in this particular grocery store for this particular case group. The pull down was not long enough. And so after each defrost cycle, there was a slug of liquid that would get sent back towards the suction header and was ultimately resulting in what we believe to be some droplets, at least, if not, drops of liquid going into the compressor itself. And so, this is the kind of thing that won't cause a compressor to explode on day one, but it will slowly wear down the compressor over time, over a period of weeks or months. And so, and then, take a 15-year lifespan and shorten it to 5 years or something like that. So this is an example where the fix was very, very easy, basically lengthening the pull down after defrost to ensure that it's kind of a smoother transition back into normal operation and eliminate that liquid slug entirely. Let's keep on going to the next one here. So, here's another example where you can, just by looking at this data, you're able to see that these various compressors, so each color represents one compressor in a suction group. You can see that these things are banging on and off all the time, many, many cycles per day, over 100 per day. And so just like Trevor was talking about earlier, when a compressor short cycles, it starts by kind of squirting out some of the oil inside of it, and then it takes a few minutes for that oil to get replenished. If you're short cycling, then you're just squirting out oil all the time. You're not giving it enough time to replenish. So ultimately, these compressors are running dry without an adequate amount of oil. And so by basically making the suction pressure control bands, relaxing those a little bit, so that the compressors could, essentially like a dead band, they can run a little bit longer before they end up cycling. And then, changing some other programming on the rack, that enabled us to reduce the number of cycles per day from over 100 per day down to just a few. And so this saves a lot on energy, but it also helps to avoid, again, the oil, kind of get the oil getting flushed out of the compressor casing. So, these are a couple examples of how data and data analytics and kind of looking at trends in data can be used to identify the root cause of issues that would otherwise kill compressors. And sometimes this could be killing compressors within 24 hours. Other times it might be shortening a lifespan from 15 years to 5 years. But in each case, this is painfully obvious in the data. And at least what we've seen in the field is that for most of our customers, so we're in the Axiom Cloud apps now are in hundreds of stores for 7 major retailers. And what we've seen is that in most cases, things like this go completely undetected. And that's not because the customer doesn't care, or I guess it is, but the customer, what they really care about, the retailer, is keeping the food cold. And none of these issues that we looked at today were related to keeping the food cold, but they would be if they had continued to persist for weeks or months and cause failures. And then the other piece is technicians. For a lot of these folks, they're stuck. We as an industry are putting technicians in an impossible position. Joe, I'd love to hear any thoughts you have on this. But basically, we're asking technicians to move faster and faster and do more and more service calls each day. And then we're asking maintenance companies to bid each other down to the lowest possible hourly rates. It's T&M not to exceed. And now customers aren't even buying parts from their maintenance companies to avoid those markups. And so we're relegating technicians into this impossible position where they have to move faster all the time, and they just don't have the time to really identify the root cause. And so that's where we think computers come in. We can help to essentially kind of fill this gap of someone needs to look at the data, someone needs to think about what they're looking at and ultimately make good decisions based on that, and then inform the technicians, how to succeed and help them be more efficient and deliver better outcomes using data, because they just don't have the time. It's not that they don't want to do it or they can't do it. We as an industry are not allowing them to do it right now. I guess, Joe, does that resonate with you, or do you have any additional thoughts on that?
Yeah, no, it totally does. I mean, there's more and more grocery stores are being built every day, and there's technicians getting hired too, but to get them up to speed to where they need to be takes time. It doesn't happen. You can build a grocery store way faster than you can train a mechanic to be a well-rounded mechanic. So It's definitely, it's hard. It's a tough thing. It takes years. It takes a long time to get to where you're confident in what you're doing. So, as a net, like, to, I guess, as an industry, it's all about helping one another. Like, Trevor said earlier, he does it for the other people. I worked with a lot of good journeymen who weren't easy on me, but taught me the skills I have today in this industry. And it's all about, passing it down to the next generation and just continuing it and trying to make it better.
Yep, makes sense. Turner, do you want to give us one question from Q&A? And I apologize, I did not mean to.
No, yeah. So we've got a few good ones, but I know some of our panelists have hard stops here at the top of the hour, and I assume some of the attendees do as well. So I actually think we might make more sense to follow up with the question askers individually here, and then kind of we can give Joe and Trevor a few seconds for any kind of final words.
That sounds good. Yeah. Apologies for folks who submitted questions, and we will get back to you. So yeah, with that, Trevor, any final thoughts on your end?
Yeah. So if you're a refrigeration professional or technician, invest in yourself. Take the time to learn it. Like Joe said, it doesn't happen overnight, and you get overwhelmed. And this is what happens with a lot of technicians. They get overwhelmed because there's so much to know. Start small, learn a little bit each day, each week, each month, each year, and you're going to get it. And the only way you're going to get it is investing in yourself. Take the time, learn, ask questions, be curious, and find people who want to help.
Wise words. Joe, anything on your end?
No, about the same thing. It's investing in yourself. We're in a generation now where, information is at your fingertips. I came up, when I started, it was all books. It was books and books and books, and then the internet started coming around, and now you can find a lot of bad information too on the internet, but there's a lot of good information on it, and it's just investing in yourself. Surround yourself with good people, good mechanics. I know sometimes the mechanics get a little competitive with one another, and you want to be around the good ones, because that's where you're going to get all your knowledge from. It's where you're going to learn it from. And it's a great industry, great trade. I've been doing it for a long time and I love it. And I just want to see it continue to grow and get better. And with people like Trevor and everyone that's working to do that, I think it's on a good path. I think we're on a good direction where we're going right now. It's just going to take time. Yeah.
Speaking of, finding information on the internet, there's this one website that I think is really good. Oh yeah, it's refrigerationmentor.com. So check that one out for anyone who's interested in learning more. And so for everyone who attended today, we really appreciate you being here. Thanks for being part of this industry conversation. Looking forward to continuing the conversation. Feel free to reach out to any of us via email. We'd love to connect and help you solve any problems that you're facing in your role. And we will be also following up with the recording to all registrants. So thanks all, and have a great Tuesday.
Awesome. Thank you so much.
Thank you.